Okay, so question number 2 is boron trihydride polar or nonpolar? So first let's find the Lewis structure of BH3. So when we write the Lewis structure, we first need to find out the total valence electrons for this molecule. So boron has 3 valence electrons and hydrogen has 1. And there are 3 hydrogen atoms in BH3, so we multiply that and get a total of 6 valence electrons. So when we write out the Lewis structure, we write boron in the middle as our central atom. And then I'm just going to write out all my hydrogens that have a single bond to the boron. Now let's count out how many electrons I've drawn so far. So if we count out 2 electrons in each bond, we have our 6 electrons already. So note that boron doesn't have 8 electrons, and this is important because boron can be an exception to the octet rule. So it's perfectly satisfied only having 6 shared electrons. So this is our Lewis structure. And now we need to find out whether or not BH3 is polar or nonpolar. So first let's examine the boron-hydrogen bond. Since this molecule is only composed of the boron-hydrogen bond. So we need to see if this bond is polar or nonpolar. And when we try to figure out if a bond is polar or nonpolar, we want to look at their electronegativity differences. So let me look up electronegativity values on the periodic table. So boron's electronegativity is 2 and hydrogen's is 2.1. So they're pretty close in electronegativity values, and the difference is only 0.1. So because it's only 0.1, then this tells us that the boron-hydrogen bond is nonpolar. So now let's look at the molecule as a whole. So not only does it contain nonpolar bonds, so it only contains nonpolar bonds, but we can also see that the molecule is symmetrical. So even if there was a slight pull of electronegativity, because BH3 is symmetrical, all these, well, not really dipole moments could cancel each other out. So we also have a nonpolar molecule. This is because it's symmetrical and because the bonds are nonpolar as well. So let's see what the junior tutor said. Polarity refers to the charge separation which causes the presence of dipole moment. Additionally, polarity can be viewed from the perspective of a bond or the entire molecule itself. A bond can be polar because the electrons are unequally shared between the bonded atoms due to their electronegativity difference. However, although a molecule has polar bonds, this does not imply that the entire molecule is polar. If the molecule symmetry results in the cancellation of the dipole moments overall, the molecule becomes nonpolar. To determine if BH3 is polar or not, let us first check if it contains polar bonds, Electronegativity difference between boron and hydrogen is only 0.16. Many references, bonds are classified as polar if the difference is between 0.4 to 1.7. So even that, usually it can also be 0.5 to 1.69. So a lot of references say different things. But below this, bonds are said to be nonpolar. Based on this, the BH bonds are all nonpolar, so the entire molecule is nonpolar as well. Yep, so this solution is correct.